When a conduit is run beneath a building at a depth of 18 inches and does not enter the building at any point, the conductors within that conduit are indeed considered to be outside the building, according to established electrical codes and practices. This seemingly simple determination has several important implications for electrical installations, safety, and code compliance. The key factor here is whether the conduit and its conductors physically enter the building's structure or envelope. If the conduit remains entirely outside the building, even though it passes underneath, it is treated as an exterior wiring method. Firstly, the type of conductors used in the conduit must be suitable for wet locations, as underground conduits are generally considered to be a wet environment, regardless of whether water is visibly present. The National Electrical Code, or NEC, defines wet locations in Article 100 as installations underground or in concrete slabs or masonry in direct contact with the earth, in locations subject to saturation with water or other liquids, such as vehicle washing areas, and in unprotected locations exposed to weather. Therefore, conductors such as THWN, THW, or XHHW, which are specifically designed and rated for wet locations, are appropriate choices for this type of installation. Secondly, the grounding and bonding requirements for the underground conduit and its associated equipment must adhere to the NEC specifications for outside wiring. This typically involves grounding the conduit to a suitable grounding electrode system such as a ground rod, ground ring, or the building's grounding electrode system depending on the specific requirements outlined in Article 250 of the NEC. Proper grounding ensures that any fault current will have a low impedance path back to the source, causing the overcurrent protective device, such as a circuit breaker or fuse, to trip and energize the circuit, thereby preventing electrical shock hazards. Thirdly, the burial depth of the conduit, in this case 18 inches, must comply with the NEC requirements for underground wiring. Table 300.5 of the NEC specifies the minimum burial depths for various types of wiring methods and voltage levels. For example, for rigid metal conduit or intermediate metal conduit, a minimum burial depth of 6 inches is generally required, while for rigid non-metallic conduit, a minimum depth of 18 inches is typically required. However, these depths may vary depending on the specific application, such as residential driveways, commercial parking areas, or areas subject to heavy vehicular traffic. Fourthly, the ampacity of the conductors in the underground conduit must be determined based on the ambient temperature and the dirty factors specified in the NEC. Underground conduits tend to have a higher ambient temperature than above-ground conduits, especially in warmer climates. Therefore, the ampacity of the conductors must be derated to account for this high temperature, as outlined in Table 310.15 of the NEC. Failure to derate the conductors properly can lead to overheating, insulation damage, and even electrical fires. Fifthly, the overcurrent protection for the conductors in the underground conduit must be sized appropriately to protect the conductors from overloads and short circuits. The overcurrent protection device, such as a circuit breaker or fuse, should have an ampacity rating that does not exceed the allowable ampacity of the conductors, as determined by the NEC. This ensures that the conductors will be protected from damage in the event of an overcurrent condition. Sixthly, the type of conduit used for the underground installation must be suitable for direct burial and resistant to corrosion. Rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, and electrical metallic tubing are commonly used for underground applications, but each type has its own advantages and disadvantages in terms of cost, durability, and resistance to corrosion. The choice of conduit material should be based on the specific environmental conditions and the requirements of the installation. Seventhly, the location of the underground conduit should be clearly marked to prevent accidental damage during future excavation or construction activities. This can be accomplished by placing warning tape or concrete markers above the conduit, indicating the presence of underground electrical wiring. The marking should be durable and visible, and it should comply with local regulations and utility requirements. Eighthly, any splices or terminations made within the underground conduit must be done in accordance with the NEC requirements for wet locations. Splices and terminations should be made using approved connectors and methods that are designed to prevent moisture from entering the connection. The connection should also be mechanically strong and electrically sound to ensure reliable performance over the long term. Ninthly, the installation of the underground conduit should comply with all applicable local codes and regulations, in addition to the NEC. Local codes may have more stringent requirements than the NEC, and it is important to be aware of these requirements before starting any electrical work. Permits may be required for underground electrical installations, and inspections may be conducted to ensure compliance with the codes. Tenthly, proper documentation of the underground electrical installation is essential for future maintenance, repairs, and modifications. The documentation should include a detailed drawing of the conduit's location, the type and size of conductors used, the grounding and bonding methods, and any other relevant information. This documentation should be kept in a safe and accessible location, such as the building's electrical panel or the owner's records. The fact that the conduit does not enter the building significantly impacts the classification of the wiring system. If the conduit were to enter the building, the wiring method would be considered an interior wiring method once it crosses the building's perimeter. This would trigger a different set of requirements regarding conductor types, grounding, and protection. For instance, the point where the conduit enters the building might require a transition to a different wiring method that is more suitable for interior environments such as electrical metallic tubing or cable assemblies. Furthermore, the grounding and bonding requirements might change depending on whether the wiring system is considered to be inside or outside the building. The NEC provides specific guidelines for grounding and bonding both interior and exterior wiring systems, and it is important to follow these guidelines to ensure electrical safety. In the specific scenario described, where the conduit remains entirely outside the building, the conductors are treated as part of an exterior wiring system. This means that they must be protected from physical damage, moisture, and other environmental factors that are common in outdoor locations. The conduit itself provides a degree of physical protection, but additional measures may be necessary to protect the conductors from corrosion, abrasion, and other forms of damage. The NEC also addresses the issue of stray currents in underground wiring systems. Stray currents can occur when electrical currents flow through unintended paths such as the earth or metallic conduits. These currents can cause corrosion of metallic components, interfere with sensitive electronic equipment, and even create electrical shock hazards. To mitigate the risks associated with stray currents, the NEC requires that underground wiring systems be properly grounded and bonded, and that measures be taken to minimize the flow of stray currents. In some cases, it may be necessary to install cathodic protection systems to protect metallic components from corrosion caused by stray currents. The depth of 18 inches for the underground conduit is a critical factor in ensuring the safety and reliability of the electrical installation. The NEC specifies minimum burial depths for underground wiring systems to protect them from physical damage caused by digging, excavation, or vehicular traffic. The required burial depth depends on the type of wiring method, the voltage level, and the location of the installation. In general, wiring systems that are buried deeper are less likely to be damaged by accidental digging or excavation. However, deeper burial depths can also increase the cost and complexity of the installation. Therefore, it is important to carefully consider the specific requirements of the installation when determining the appropriate burial depth. The location of the electrical installation in Massachusetts may also have an impact on the applicable codes and regulations. Massachusetts has adopted its own version of the NEC, which may include amendments or additions that are specific to the state. It is important to be aware of these local requirements before starting any electrical work in Massachusetts. In addition, Massachusetts may have its own licensing requirements for electricians and electrical contractors. Only licensed electricians are typically allowed to perform electrical work in Massachusetts, and they must comply with all applicable codes and regulations. The determination of whether conductors are considered inside or outside a building has significant implications for electrical inspections and permitting. Electrical inspectors will typically examine the wiring system to ensure that it complies with all applicable codes and regulations. If the wiring system is not installed correctly, the inspector may require that it be corrected before issuing a permit or certificate of occupancy. The permitting process is designed to ensure that electrical installations are safe and reliable, and that they comply with all applicable codes and regulations. It is important to obtain all necessary permits before starting any electrical work. In summary, when a conduit is run beneath the building at a depth of 18 inches and does not enter the building at any point, the conductors within that conduit are considered to be outside the building. This determination has several important implications for electrical installations, safety, and code compliance. The type of conductors used, the grounding and bonding methods, the burial depth, the ampacity of the conductors, the overcurrent protection, the type of conduit, the location of the conduit, any splices or terminations, the local codes and regulations, and the documentation of the installation must all comply with the NEC and any applicable local requirements. Proper planning, design, and installation are essential to ensure the safety and reliability of the electrical system.